We've been given an ellipse with an x-axis radius of 6, so the total distance across is going to be 12, and y-axis radius of 2, so the distance across here is going to be 4. And we're being asked to find the largest rectangle that can be inscribed in this ellipse. So we're going to maybe simplify this problem a little bit in that we're going to just take a look at one quadrant. And if we maximize the area in that one quadrant, we'll maximize the area of the whole rectangle. And to find the point at which is going to give us the largest rectangle, what we want to do is we essentially want to find this coordinate here. And so first things first, we need to come up with an equation that we're going to maximize. We're maximizing area, so the area is going to be the length times the width. And we can rewrite that as the x position times the y position. So x times y will give us the maximum area. Now the problem here is that if we try to differentiate this to find the optimum point, we have too many variables. So what I have to do first is I have to express this y in terms of x. So I need to rearrange this expression and solve for y. So I get y equals 1 minus x squared over 36. We're going to times that all by 4 and square root it. So we're going to end up with 2 square root of all that. So this equation then represents the y position of that coordinate, and we have the x position. So if I rewrite this equation, then I end up with a as a function of x is now equal to x times 2 root 1 minus x squared over 36. Okay, so there's my function that I'm going to then differentiate. Okay, so I've got my equation that I'm going to optimize. I've expressed my equation in terms of x, one variable, by using the other relationship to come up with the other variable. I'm now going to differentiate this to be able to get a derivative which I can solve for equal to 0. So I'm just going to pull the 2 out. So I end up with square root 1 minus x squared over 36 times 1 plus x times the derivative of the square root function is going to be 1 over 2 square root 1 minus x squared over 36. Okay, I'm going to then multiply using chain rule, so I'm going to end up with 2 over 36 times x, so it's going to be negative 2 over 36x, and there's my expression for my derivative. Now I'm just going to need to simplify this a little bit and make it equal to 0. Since I'm going to make it equal to 0, what I'm going to do to simplify this is I'm just going to multiply everything through by the 2 square root in the bottom. So I'm going to end up with 2 times 1 minus x squared over 36. Okay, when I multiply through this, I'm going to get rid of the denominator, so I end up with minus, oops, I'm just going to put a bracket around that, minus, this is going to be 2 over 36 x squared. Just double check that my 2 over 36. Okay, and x times x is x squared. So there it is. Okay, and then this is equal to 0. Simplifying this a little bit, I'm going to just get rid of that 2 on the outside, so I end up with 2 minus 2x squared over 36 minus 2x squared over 36. This becomes 4x squared over 36. That's equal to 0. Simplify this, this becomes 2 is equal to x squared over 9, and x is equal to plus minus square root of 18. So there's my x that would maximize the area. And it says find the largest possible area. So using that value, I'm just going to plug that into my area function. Okay, I can either plug that in to solve for y, or I can just plug it directly into my area expression, which is what I'm going to do here. So I'm just going to do this in a different color. So I'm going to take this equation here. Area when x is root 18 is equal to root 18 times 2 minus, or 2 times square root 1 minus root 18 squared is 18, so it becomes minus 1/2. And I end up with 2 times square root 2 divided by root 2, so it becomes root 18 times 2 divided by root 2. Okay, so that, just double check that's right. That's going to be square root of root 2, square root of 1/2, which is root 2 in the denominator. And so I end up with, this is going to be 18 divided by 2 is 6. Sorry, 9, square root of 9 is 3, so this works out to be a value of 6. And that's 6 units squared. And that represents the area in the one quadrant. So to find the total area, the largest area, which I'll just change colors here, the largest area is going to be 4 times that, which is going to be 24 units squared. So there's my solution.